So the periodic table has columns. These are the up and down vertical parts. So these are columns, and that makes these left to right rows. Except on the periodic table, they're not called columns and rows. The columns are called groups, and the rows are called periods. Now on the periodic table, there are 18 groups, and the number is usually right on top of the column. There's some Roman numerals highlighted in yellow. That's for the main group elements, just the main group elements. So 1, 2, 3, 4, 5, 6, 7, 8. But the whole 18 groups have the number at the top. The period numbers go down the side. So there's 18 groups and 7 periods. Now you might ask, what about those two sections at the very bottom? Well, if you pay attention to the top left-hand corner, that's the atomic number. So the atomic number of the first one is 57. And here, on period 6, you jump from 56 to 71. So basically, these two rows squeeze in right here. But then the periodic table would be really wide. So basically, we take them out and we put them at the bottom. But it's understood that they fit in right there. So they are still period 6 and 7. Now the periodic table can be used to help you do a whole bunch of different things. The period numbers here also correspond to the rings in a Bohr diagram. So in theory, there could be 7 rings, but basically hydrogen is bumped up a little higher here just so it's recognized that it's not part of the first family. It's in the first column, so it's in the first group, but it's not an alkali metal. These are the alkali metals. This is a non-metal, but it belongs here. So on the first row, we have hydrogen and helium, so 2 elements. On the second period, on the second row, we've got 1, 2, 3, 4, 5, 6, 7, 8 elements. On the third row, the third period, we've got 1, 2, 3, 4, 5, 6, 7, 8 elements. These correspond to the rings and the possible electrons on Bohr diagrams. So if we look at the Bohr diagrams, the first ring corresponds to the first row of the periodic table. Second ring, second energy level, corresponds to the third row of the periodic table. Sorry, the second row of the periodic table. And the third ring corresponds to the third row or third period of the periodic table. And you can keep going. So you get up to 7 rings. You don't have to draw a ring like the third energy level if you only need up to and including the second energy level. But basically, if I fill in one of these dots, I've just drawn the Bohr diagram for hydrogen. If I've done 2, that's helium. That would be lithium. It's 3 electrons, so that means the atomic number is 3. and the atomic number identifies which element it is. So the atomic number of 3 is right here, so we know it's lithium. So the periodic table can help you fill in your Bohr diagrams. Anything on the first row is in the first ring. Anything on the second row or second period is on the second ring in a Bohr diagram or second energy level. There's more information that we can get from the periodic table. So the group number also helps us with the number of valence electrons, so the number of electrons in the atomos shell. So basically, if we look at the Roman numerals here, column 1 has 1 valence electron, column 2 has 2 valence electrons, 3 valence electrons, 4 valence electrons, 5, 6, 7, and 8. What you can also do is look at the group number, except, like here, 1, 2 valence electrons. Over here to the right-hand side, you look at the last number of the group number, and that will tell you how many valence electrons. And that you subtract 10 for these 10 transition metals. So either way, you can get the number of valence electrons directly off of your periodic table. For that reason too, you can mark up your periodic table and put in the charges that will occur within that column. Because the left-hand side of the periodic table is metals, they're going to lose and become positive. So basically, everyone in group 1, when it forms an ion, will lose 1 electron and will become 1 plus. Everything in column 2 will become 2 plus. Column 13, 3 plus, because they have 3 valence electrons. Now this 14th column can be 4 plus or 4 minus. It's where it switches. But now we're into the non-metals as well. So group 15 has 5 valence electrons. It's a non-metal, so it gains. They gain electrons, so they want 3 more to be full. Group 16 wants 2 more to be full. Group 17 wants 1 more to be full. They have 7, 1, 8. And then the noble gases don't add any electrons because they're already full. So elements are going to gain or lose electrons depending on whether they're a metal or a non-metal. So metals are going to lose. And they lose electrons so that they basically empty their valence shell. Non-metals, these are the elements on the right-hand side. The non-metals are going to gain electrons because they want to fill their valence shell. So however many they have, the charge they form depends on how many more they have to be full, like the noble gases. So your periodic table can help you do a lot of things. What we haven't talked about is the number here in the top right-hand corner. These numbers we'll be using later when we get into bonding. So their electronegativity. Okay. Let's just make this bigger. All right. So on the periodic table, you have this number in the top left. This is the atomic number. So that tells you how many protons you have, how many electrons you have. By definition, it's the number of protons. Because an atom is neutral, it's also the number of electrons. So this is, as I mentioned, the electronegativity value, En for short. We don't talk about that until bonding. And this number below, this is the atomic mass. It's an average number, so they take the average of all the isotopes. So it's an average, so basically we can round it off to the nearest whole number, and then it becomes the mass number for when we calculate the number of neutrons.